Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to see about a topic from automatic generation control, and the name of the topic is concept of area control error, that is ACE, in a single area and two area. Now in the case of single area, the ACE is nothing but a change in the frequency. So we can write ACE, here I write it as a single area. When we are talking about a single area, then this ACE is nothing but what? It is change in the frequency. The steady state error in the frequency will become zero, that is delta FSS. This SS stands for steady state. Delta FSS will become zero when the ACE used in the integral control loop. On the other hand, when we talked about a two area case, then it is a linear combination of change in the frequency and change in the tie line power. So let's see again about area control error in the single area. We know that when we talked about the integral control, then it consists of a frequency sensor and the integrator. What is the use of this frequency sensor? It is used to measure the error in the frequency, which is denoted by delta F. And this error signal is fed into the integrator. So if you see the block diagram representation of effect of integral controller on this single area load frequency control. So from that block diagram, you will be able to see that output of the block diagram is delta F, and then which is given to the integral block, which is minus Ki by S. So it is given to this. So the input to the integral is called as area control error. So what is the input to the integral? This is nothing but change in the frequency delta F. The ACE is the change in the area frequency, which when used in an integral control loop forces the steady state frequency error to zero. Already in the effect of integral controller, we have seen that when we use this integral controller, then the change in the frequency will become zero. So therefore, the integrator produces a real power command, which is nothing but a delta PC. It is denoted by what? It is denoted by delta PC. And how we can define this delta PC? It is nothing but minus Ki. Now why minus? Because here we have taken minus Ki by S. So minus Ki integration of delta F dt. So this delta F dt, or we can say delta F, is nothing but what? ACE. The signal here, delta PC, is fed to the speed changer, causing it to move. Now what is this Ki here? This Ki, it is also called as integral gain constant. And why it is used? It is used to control the rate of integration. Here, why this negative sign is there? The negative sign is because of producing a negative or decrease command for a positive frequency error. If you see, the change in the frequency is more, then we have to reduce that change in the frequency. So that's why here negative sign is to be taken. The gain constant, which is Ki, is a positive and it controls the rate of integration and therefore the speed of the response of the control loop. The integrator, what is this? Integrator is basically an electronic integrator of the same type as used in the analog computer. So if the question is asked, area control error in the single area, then basically it is nothing but what? It is nothing but change in the frequency, which is denoted by a delta F. Now what is to be there in case of two area case? As I told you earlier, ACE is the linear combination of change in the frequency and change in the tie line power when we talked about a two area load frequency control. Now in this case, in order to make the steady state tie line power zero, that is steady state tie line power is represented by delta PTL, which is equal to 0, we have to use another integral control loop for each area must be introduced in addition to the integral frequency loop to integrate the incremental tie line power signal, and which is feed back to the speed changer. So therefore, if you see here, for control area 1, if I have a control area 1, if I have two control areas, in two area load frequency control, already we have seen this. This is your A1, this is your A2. So how we can write area control error in area 1? It is nothing but what? It is nothing but delta P12 plus beta 1 into delta f1, where this beta 1 is nothing but a constant which is called as area frequency bias. So I write it here. This is area frequency bias, which is beta 1. And if you see now, if I take here Laplace transform, then what I will get? I will get it like this: ACE of 1 of S, because we are taking Laplace transform, equal to what? I am going to take a Laplace transform of this term. So delta P12 of S plus beta 1 is the constant and delta F1 of S. So you can take this as a equation number 8. So what is this? This is nothing but area control error of area 1 when it is interconnected with area 2. Similarly, I can write area control error for area 2. Directly I am going to write it in a Laplace form. So which is equal to delta P21 of S plus beta 2 into delta F2 of S. So treat this as a equation number B. So here we have seen that how we can write this. This is your equation number 1, which was same as that of this. This is your equation number 2. So therefore this is the difference between ACE in the single area and 2 area. So again, in short, I will write it here. When we talked about a single area, then for single area, area control error is nothing but what? Change in the frequency, that is delta F. And when we are talking about a 2 area concept, or 2 areas which are interconnected with each other, then in that case it is the combination of a change in the frequency and change in the tie line power. So that's why I can write it as, if it is for area 1, then it is delta P12 of S plus this beta 1, it is nothing but area frequency constant into delta F1 of S. So this is what is the concept of area control error in a single area and 2 area. Thank you for watching this video.